Hey guys, and welcome back. So let's talk about collision geometry coming in from SOPs. Now, when we do destruction, if we have, let's say, a group of RBD objects, let's say multiple spheres, for example, hitting this building, and the spheres are active. When we apply a force to push them this way, they will be moving at a certain speed, and the change between different frames will be impacted by the number of sub-steps in the bullet solver. Okay, let me delete this. Bullet. Okay. So the number of sub-steps here, if we have a sphere moving this way, the number of sub-steps is going to affect the interpolation of that sphere between the frames. So when we move from frame 1 to 2, it's going to evaluate the position of that sphere 20 times, which will give us accurate information. When we use something from SOPs, let's go up. The setup here, quick note, the setup here is a bit different. My scene crashed for some reason. I'm not sure why. Houdini just quit. And I used the shelf to build it again quickly. So let me explain something with the sphere. When we have a sphere, let's add some animation here. I'm gonna use $F, delete. Okay, so it's moving from left to right, and if we preview the subframes, so I'm gonna turn this off and set this to 0.1. So we're seeing 10 we have 10 subframes. If you look at the frame here, it says 1.1, 1.2, but it doesn't change until it hits certain points. Okay, it doesn't change yet. It doesn't change in between those sub-steps. And the reason for that is because we're using $FF, and $FF will give us back the frame number. What we need to use is $FF, and this gives us the subframes. Now see how the sphere is moving and providing data between the subframes. This is important for DOPs because, or for bullet sims, because now we have that information available, but no matter what the bullet settings that we use in the substeps, it's not going to reevaluate the sphere position between substeps. This is only affecting, this guy only affects the RBDs inside DOPs. If we have something coming from DOPs, from SOPs, sorry, what affects the evaluation of SOPs data is the DOP network substeps. This is the guy that will force anything in DOPs to get evaluated twice. So this way, if let's say we have a wall here, if the sphere is moving at a certain speed, let's increase this to say 10. Okay. 10 minus 10, so it goes back to 0. And let's template this. Now if I move between the frames, see one frame it's here. Actually, let's not check the in-between frames, the subframes. Now we're frame 1. When we go to frame 2, the sphere is beyond the wall. It didn't even detect it. Okay, so if we do this sim, if we use the speed and this is an RBD wall, nothing is going to happen. What we need to do is we need to increase the substeps so that it reevaluates the DOP input as many times as needed for it to capture that animation. So in this case, if we set this to 0.2, for example, here, so it means 5 substeps in between the frames. Now this is 1.2, 1.4, 1.6, and so we increase this guy to 5, for example, or 6, and we make sure that the data coming in SOPs can be interpolated between subframes. If we use $F, doesn't matter, it's not gonna change. Okay, see, it's not gonna do anything because it's not generating the subsamples. Now this is an example of a sphere moving. What if we have something deforming? Okay, let's hide this. And let's create a mountain node. And let's increase the height. I'm going to put down a blend shape node. And I think this is, yeah, it's new in Houdini 70, so it may fix this, but I'm going to try and explain when it fails. So in this case, I have a blend shape doing this. And let's say this is a character transforming from one frame to another. It's going to deform. Okay. Let's take a look at the let's animate this guy. So I'm going to set the key here to 0. I'm going to go to frame 4. Set it to 1. Okay. And let's take a look. Now see the subframes. There is data in between the subframes. And this is something very, very important. And I'm going to see if I can turn that off. And I think I can mess it up here. If I do a sort and random, I'm going to use $FF. Yep. So I know this is weird, but I'm messing with the interpolation with a point number, which is used to drive for the blend shape to know what point to blend to. But if the geometry did not have in between samples, in between subframes, it's going to be impossible for us to get accurate deformation from it. So we have to make sure that we have that information we provided for DOPS, so that when we increase the subsamples, we have enough data to capture all the movements. If, for example, Kong is moving his hand or anything like that really, really fast, we need to be able to capture that. So I'm going to import the geometry. And let's turn off subsamples here. And the animation starts at frame 154. Sorry. So let's put down the time shift node. Plus 154. This is just an offset. Okay, and that's our guy. If we play, should see the movement there. Cool. So I'm going, it's the ABC file contains a lot of stuff, and I'm going to isolate it to only show me the data I need. So I'm going to browse for make select geometry, and I'm going to import everything. So this is our guy. Okay, and let's take a look at the subframes. So I'm going to set this to 0.1 or 0.2. And let's scrub through, let's play through, and see, it's not changing in between there. So this data is not ready for to be used in DOPS, and it's not going to give us accurate collision, because if it moves too fast, we cannot use the DOP substeps to capture all that stuff. So what we need to do is we need to first unpack the geometry, because it's alembic and it's packed by default. So we need to pack it, and I'm not going to use, I'm going to convert it to polys, even though polysoup works, but I prefer to keep everything poly. And let's take a look. Now we still have the same issue, no subframes. The way to fix that is using a time blend node. Okay, so the time blend node, this is new in Houdini 17, and in fact it's the retime node. So they have a retime 2 node called retime 2 that replaced the alt time shift and the time warp, and it works with volumes and stuff. So it's great. And now you can see we have subframes. So the conclusion to this: always use a time blend. If you have deforming geometry, always unpack it and use a time blend. Okay, now let's create a null and import this guy for destruction. I'm going to call this out collision Kong geo, and let's copy this. I'm gonna dive inside, not this guy, sorry. I'm gonna go up here and let's create a static object. And paste the path. And let's put down a merge node. Okay. And let's go back to frame 1 and make sure this is set to 1. And let's take a look. Now obviously Kong is going to be way off, but I'm not worried about that. I want to show you guys something here. So let's play, and nothing is changing. The reason for that is because we need to tick on use deforming geometry, and everything is working as expected. Cool. So let's take a look at the collision geometry. If we go under bullet data and take a look at the bullet guide, this is a convex hull that is generated for Kong automatically, and this is what bullet is going to use for collision. And obviously, as you can see, it's not going to work. If we change this to concave, it should give us something. Yeah. If we change this to concave, it's going to give us a much better result. It's actually wrapping the geometry perfectly. But this is going to be slow as hell. Okay, it's actually not going to be stable. Even with this, it's not gonna give us the geometry that we want. And the fact that the geometry is deforming quite a bit is gonna cause a lot of issues. I'm telling you guys because I know all the issues that comes with this. I'm gonna show you the solution for this in a bit. So none of these guys are going to work for us. So what we need to do is we need to generate a static geometry made of multiple RBD objects that don't change over time. And the way we're going to do this is by converting the geometry into an SDF and then converting this SDF into multiple spheres. We're going to pack spheres into this SDF, and so we'll have sphere representation, or we'll have multiple spheres filling this volume and describing the silhouette with a lot of details. And then we're going to take those spheres and deform them. They're not, the spheres themselves, they're not going to change over time, but they're going to be deformed. And so that's what we're going to do in the next video. Thank you guys for watching, and see you in a bit.